Hi, my name is Christian Kasilag, and I am going to present my Carnegie Mellon 15112 term project. I did my project on 3D reconstruction of 2D images. I wrote a program in Python that will take an image with some drawings on it and transform them into a 3D object that can be visualized on the computer screen. Each drawing, as you may be able to see here, has to have some shapes that all correspond to each other and have faces that line up. And these drawings can be done in pencil or pen, just on a normal sheet of paper. And then the user can take a picture of this drawing and then send it to this program, and then it will turn it into a 3D object. So I guess we can jump right in here, and I'll click Load Image and select this one, Step Block. And basically the program will start up. Okay, as we can see here, this is the user interface. The user is allowed to first see this image that he just selected. As you can see here, it's sort of a step block. It has a step shape here, and then this would be the top face, this would be the rear face, bottom face, this is the front face, and these are two side faces here and here. If I go ahead and press Detect Corners, these red dots appear along all the vertices on each of these faces. These represent the corners that were detected based on a corner detection algorithm that is somewhere in my program. Basically what these points do are these points represent where the faces are, and then these faces can be translated into 3D coordinates. So if I go here and go and click Display 3D Object, then you can see some lines appear in this window, and these are actually these faces. You can see the shape come here. There is mouse motion capability for rotation, so I'll go ahead and rotate this, and right away you can see that that shape has just appeared in this window. It is easy to notice that the faces are very broken, and the points are not connected in any way, and this is probably not what the user would want. In order to solve this, I've incorporated a button this button that says Unrefined Vertices, and right now it's set to Unrefined Vertices, but if I click it, it goes to Refined Vertices, and my program has actually taken all the points near one point and condensed them into single points, so it actually turns all those broken points into nice, clean, concise points that make up a shape that the user was really thinking about. So the final option for visualization would be changing the wireframe setting to a colored face setting. So go ahead and click this button, and then you can see the shape with colored faces rather than in a wireframe. We can go back, switch back to a wireframe, switch back to colored faces, and view that in the broken setting, and then basically you can tell how your object turned out. So I guess that's it for the program's features. It's a very small user interface, but I guess the implication of this is pretty big. Going into the code over here, it is possible to see exactly just what is going on here. So we start out with a corner detection algorithm, and then that is what we can see here, detects these corners. And then after the corners are obtained, we go through a lot of manipulation functions that deal with getting the faces, so getting these 6 points to be one face, these 4 points to be one face, and there are a lot of functions that deal with making sure that the right points go to the right face. And then once all that is done and all these faces are obtained, there is a large function that converts everything to 3D points. So it takes these 2D points and then converts to 3D. The way this works is based on the shape of based on the size of each shape, or the largest shape. A z-axis coordinate can be obtained from just a 2D plane, and this 2D plane can be projected into 3D space. So basically I go through each of these faces and I perform one 3D conversion function, and as you can see here, the X 3D, Y 3D, and Z 3D components have been defined. These are all added to one list, and then these are transported to my visualization program, which is a series of classes, this Reconstruction class. So this Reconstruction class deals with all the visualization features, the refine vertices features, and then the mouse rotation features, as well as coloring the faces and assigning the faces to different locations in 3D space. I guess that's about it. Thank you very much for your time, for taking your time to watch this video, and I hope you enjoyed it.